Good morning everyone. Welcome to the session on matrix based problems. I hope you have gone through the previous sessions and they have been useful to you. We have done sessions on, one second. Okay. We have done sessions on cryptarithmetic first, and then we started seeing subsections of percentages because normal percentage problems will be covered in regular classes. We wanted to focus on niche topics that people seldom teach in classes. So another session was on election based problems. Okay. And in the same theme, today we are going to see problems on matrix based problems. They are a subset of percentage based problems, but although the nomenclature might seem unfamiliar to you, it is nothing but okay. Matrix based problems are, just to give you a snapshot, matrix based problems are those problems where one, in the name itself, okay, the solution to the problem becomes easier instead of thinking it in linear terms. If you do a matrix, okay, matrix generally contains is an arrangement of rows and columns. So all such matrix based problems are those problems where the solution to the problem becomes much more easier if you are able to fill the information in the form of a matrix. Okay, and what type of questions, to give you a general meta sense of such type of problems. Okay, these problems will have something like this. There is a super category. For example, this might be a school or a class or a village, okay, so on and so forth. In that super category, there will be subcategories. Okay, mostly the complexity of the problem gets increased as more and more subcategories increase. For example, I could tell you subcategories could be men, women, okay, and further subcategories could be okay, men, women. They might be illiterate, literate, boys, girls, somebody who have passed the exam, somebody who have failed the exam or not passed. Okay. So all matrix based problems will have a common meta theme of this. There will be a super category and there will be subcategories, where a super category will be divided into men and women, and within the men and women there will be literate and illiterate, or there might be someone who is employed, unemployed, so on and so forth. Okay, so for all such based problems, okay, the easiest way to solve such problems is form a matrix based upon these categories and subcategories. For example, if I say okay, girls and boys, some X percentage have passed the test in girls, some Y percentage has passed. So what do? Okay, there are girls and boys. Okay, next, among girls who have passed, among boys, or among girls who have not passed. Now both girls have the categories of passed and not passed, and both boys also will have passed and not passed. Okay, and the easier, because most of the time I am giving you a general sense of this, most of the time, okay, rather than giving you this directly, the examiner wants to check your applicative ability. So what does he do? Okay, one way is provide the information here directly. Suppose this is some 35% of the girls passed the exam, so on and so forth. But tricky examiner who wants you to see your applicative ability, what does he do? He gives you in terms of total. For example, in a class, total 40% of the students passed. Now Okay, because the information is not direct, you need to derive from this part of 40% what are the girls that have passed, okay, or what amount of boys have passed the exam. Okay, so this is how examiners like to twist. Okay, instead of giving you direct information, they'll give you this. I hope you have gotten a sense of what matrix based problems are. The first observation is just form a matrix and try to fill the information that is given there. Okay, this is one observation that I would like to tell you. Next one is, these are common. If you would have followed the sessions of my percentage and percentages like election based problems and all, you would have gotten the common things. Like, to do any percentage problems, it is always advisable for you to be dynamic in your approach. What do I mean by that? Don't see percentage as in silos. Don't see percentage as just as a percentage. Okay, when there is functionality, further functionality, see it as ratios. See them as ratios. Or when the question allows you to solve an easier solution, allows you to get to an easier solution, see them as fractions. Always be dynamic. Don't think in silos and don't see percentages, okay, just as that. Okay, and we have discussed this commonly in previous sessions, and I hope you would have gotten used to it by now. Okay, all the percentages and their fraction conversion. So you should be good with percentage and their corresponding fraction conversion. Percentage to fraction conversion. Okay, and the fourth one is just like we have discussed in session 2. The fourth one is, there are only two ways to solve problems, or two efficient ways to solve problems, especially percentage problems. Okay. One is the problem of, okay, the solution of taking initial value as 100x. Hello. I hope the voice is clear now. Sorry for the technical delay. I had some of you telling that there was some background noise. Is this clear now? Hello. Okay. If you have any problems, kindly intimate in the comments. I hope it is clear now. Okay. Let's start. Okay, we were talking about the ways to solve any percentage problems. These we have already discussed in the previous session, so we'll just one way is taking value as 100x. Okay, and next one is using ratios and using multiplication factor. Okay. And we have commonly seen that in percentage problems, when the percentages are 20, 30, 40, generic like this, it doesn't matter whatever you take. Initial values you take 100, 50, 60, it doesn't matter. But one important observation that I have been focusing on, or that I have been highlighting in the past sessions, was always be very, very careful about your initial value. Okay. Your initial value, the way you take an initial value may make or break your solution. So these are the common observations that we have seen in the previous sessions, except the first one, which is specific to our matrix based problems. Okay, the easiest way to solve all the matrix based problems is, okay, just form a matrix. Form a matrix and try to fill all the forms. And once you fill this, you will see, I see most people getting confused regarding matrix problems is because when they give 3 or 4 parameters, it becomes difficult for you to imagine the idea or think about this thing. Most matrix based problems are difficult because people are unable to visualize the idea. So the first observation that we have discussed today, okay, just form a matrix, okay, and you will see that the solution to the problem becomes much more simpler. Okay, so I hope I have given you enough introduction. Now it is not, we are not satisfied with the theoretical part. Okay, now we'll implement all these observations that we have seen till now and see how easy the problem becomes. And always the format has been the same. Okay, I'll write a question, I'll give you a question. Okay, please do not hear to this like you hear a story. Please don't do that. It is not effective way to study at all. Okay, I'll discuss the question. I'll give you, if there are any difficult points, I will make them easy for you. Pause once. I'll give you an indication for you to pause the video. Pause the video and then solve it for yourself. It is good and it is appreciable that even if you don't solve the question, I am happy with it. You should make mistakes. Okay, and after solving, after you solve for yourself, then unpause the video and compare your approach with mine. And what approach, what do you need to update in your approach better. Okay, compare, and then only you will be able to learn much more effectively. Okay, and hearing this like an story doesn't give you much benefit. Okay, you might know the solutions, but the aim of these sessions are to make you a better thinker. Okay, so the answers are not important here. Your thinking is much more important here. So with this, always I'll give you some time, I'll give you an indication, pause the video, solve for yourself, and then compare your answer with me, and then update yourself. Okay, so let's start with question number 1. Okay, I'll be giving you, okay, in recently held elections, okay, so question number 1, matrix based problems 1. In recently held elections, there were 2 parties. In recently held elections, there were 2 parties, A and B. Okay, 30% of the total voters, 30% of the total voters promised to vote for party A. 30% of the total voters promised to vote for party A, and the rest promised to vote for party B, and the rest promised to vote for party B. Okay, on the day of elections, 20% of the voters, on the day of elections, 20% of the voters, 20% of the voters, 20% of the voters who promised for A, 20% of the voters who promised for A went back on their decision. That means they did not vote for party A. Okay, 20% of the voters who promised for party A went back on their decision. Okay. And in the same way, 30% of the voters, 30% of the voters who promised for party B, 30% of the voters who promised for party B went back on their decision, went back on their decision. Okay. Party A lost the election. Party A lost the election by 1500 votes. Party A lost the election by 1500 votes. Party A lost the election by 1500 votes. Okay. Find the total number of voters. Find the total number of voters. Find the total number of voters. Okay. For the sake of clarity, I am repeating this again. Okay. There were some voters in an election, okay, and party A and party B were participating in it. Okay. 30% of the voters promised to vote for party A. 30% of the voters promised to vote for party A. And 70 remaining people promised to vote for party B. Remaining people promised to vote for party B. Next. So it is not that like we always keep our decisions. So on the day of the election, 20% of the voters who promised for party A, 20% of the voters who promised for party A went back on their decision. And in the same way, 30% of the voters who promised for party B, 30% of the voters who promised for party B that they will vote for them went back on their decision. Okay. And as a result of this, A lost by 1500 votes. A lost by 1500 votes. Okay. Now, the examiner wants us to find the total number of voters. Find the total number of voters. Okay. I hope you have understood the question. Kindly pause the video here. Pause the video. Solve for yourself. Okay. And then we'll see the solution in a few seconds. Kindly pause the video and unpause it only when you have solved the solution, and then compare and learn. Okay. We'll see the solution in just a few seconds. I want all of you to try to solve the question. Good mistakes are good here, and they are encouraged to. Okay, I'm starting the solution. 1, 2, 3. Okay, so I'll just reduce this to okay. So let us see the solution. You see that here that there is a super category of A and B. Okay. Although it might not be apparent, but something has happened in two situations. Something has affected both. Okay. All matrix based problems are like that only. Okay. Suppose for example, there are males, there are females. Okay. Whatever I write in this rows, passed, not passed. Males have passed, some males have failed. In the same way, females have passed, females have failed. Okay. So whatever you write in the column sense or in the row affects both of the columns. Okay. That is the advantage of arranging the information in form of a matrix. Okay. So let us see the question now. Okay. I know taking all of the information at once might seem daunting. So whenever you solve percentage problems, always approach step by step. read a line, understand it fully, okay, and try to implement in your solution. So I'm going step by step, okay, not just okay, because it seems efficient, but going step by step also gives you an indication of how to think, what are the attacking points that are there, okay, and how should I proceed. Okay, so party A and party B, party A and party B. Let me write the solution in a different color. Okay, I'm choosing white. Okay, so party A and party B. So this is before election. Okay, this is at the time of election. Okay, at the time of election. Okay, so what has happened? Party A 30%. Okay, 30%. You see the percentages involved. 1, it is 30% here, so 70% here. Okay, so the first observation that comes into play in this is, since the percentages are regular percentages, I can get away with assuming the value as 100. So what happens here? Suppose I assume the total number of voters are 100x. Okay, because we all are habituated with taking initial value as 100 for solving percentage problems, and the percentages given seem to allow us. Okay, so I'm not making it extra complex by doing it in a ratio way or multiplication factor way. So assume value of 100x because the percentages allow us. So now, 30% of the voters, that means 30x, promise to vote for party A, and 70x promise to vote for party B. Okay, so what happened on the day of elections? Okay, so before 30x promise to vote for party A, 70x promise to vote for party B. Next, on the day of elections, okay, 20% of voters who promised, 20% of voters who promised to vote for party A. Okay, so what is 20%? To solve this easily, what is 20%? Consider equivalent percentages. 20% is 1 by 5. So 1 by 5 of 30x, which is nothing but 6x. Okay, 6x went back on their decision. That means I'm just showing minus. That means 6x people voted for party B. On the day of election, they voted for party B. Now, okay, what is the second case? Second case is 30%. 30% of people who promised for 30% of the people who promised to vote for party B went back on their decision. So 30% is, okay, 30% is 3 by 10. 30% is its equivalent. Okay, percentage fraction is 3 by 10. 30%. 10% is 1 by 10. 30% is 3 into 10% or 3 into 1 by 10. So 3 by 10. So how many people went back on their promise? Okay, 70x into 3 by 10. Okay, 7 3s are 21x. So 21x went back on their promise. 21x went back on their promise. Okay, now this is where you need to apply. You see, there are only apply your analytical skills. You see, there have been some changes. There are only 2 parties. Okay, there have been some changes. You see, what is the effective change that has happened? Okay, the easiest way to solve this problem is what is the effective change that is happened. One way to solve this problem is, okay, and rather than telling you the simplest way, you see, we will do, because this 6x have gone back from voting to party A. Okay, so that means they have voted for party B. Okay, and this 21x have gone back on their promise. Have gone back on their promise. That means they would have voted for this. Okay. Instead of seeing this separately, okay, one way is treat each of the changes individually. So 30 minus x, okay, people who promised to vote here voted here. So this becomes 70 plus x. In the same way, 20% voted here, and in the same way 70x, 30%, 21x who promised to vote here voted here. So this, okay, this is one way to solve. But a much more efficient way is see the net change. Instead of seeing those changes individually, see the net change. You see, 6x has moved in this direction, 6x has moved in this direction, and 21x has moved in this direction. So what is the net change? Net change is 15x. 15x have moved in this direction. 15x have moved in this direction. So what are the total number of people who have voted now? 30x plus 15x. 30x plus 15x. And from where did this 15x come? There are only two parties. If one is increasing, that means it has to come from the other. So it becomes 70x minus 15x. Okay. So this will be 45x and this will be 55x. So on the day of election, 45x voters voted for party A and 55x voters voted for party B. Now what did he say? He said, okay, party A lost by 1500 votes. Party A lost by 1500 votes. So what is the difference here? Party A lost by 1500 votes. That means the margin is 1500. And what is the margin? In x terms, it is nothing but 10x. 10x is equals to 1500. What are the total number of voters that we have taken? 100x. So 100x is nothing but 15,000. Okay, 100x is nothing but 15,000. So the total number of voters in the voters list are how many? 15,000. Okay, 15,000. I hope the solution is clear for you and you got an whiff of how to solve such matrix based problems. Okay, first find the matrix. Okay, whenever you see a super group and subgroups given, okay, always try to arrange the information in form of a matrix. It becomes much more easier. Okay, now let's go on to the second one. Okay, the second question is, in a country A, in a country A, okay, in the year 2022, in a country A, in the year 2022, oh, this is 2025, right? Let's take recent. In the year 2023, rice production. In the year 2023, rice production was 35%, 37.5%. Rice production was 37.5% of total food grain production. Okay, so in a country A, in 2022, the rice production was 37.5% of total food grain production. Okay, so in the year 2024, rice production increased by okay, rice production increased by 31.66%. rice production increased by 31.66%. Okay, rice production increased by 31.66%. But rice production increased by 31.66%. But rice production as a percentage of total food grain, rice production as a percentage of total food grain, okay, decreased by 17.75 percentage points. 17.75 percentage points. 17.75 percentage points. 17.75 percentage points. Okay. Now find the percentage increase. Find the percentage increase in total food grain production. Find the percentage increase in total food grain production from 23 to 24. From 23 to 24. Okay, I am repeating the question again. There is a country A. In year 2023, the rice, okay, country normally produces its own food for its sustenance. Okay, so rice production was 37.5% of the total food grains. Okay, 37.5% of the total food grains. In 2024, the rice production increased by 31.66%. The rice production increased by 31.66%. But as a result of this, what has happened? Okay, but they have observed that rice production as a percentage of total food grains, decreased by 17.75 percentage points. Okay, be very, very careful here. I am not telling you it decreased by 17 percentage. It decreased by 17.75 percentage point. That means it literally suppose if I say x percentage points, something decreased by x percentage points. Initially, if it was 20%, okay, then it became 20 minus of x percent. Okay, this is what you call percentage x points. This is what you call percentage point. That means there is a direct decrease. He has given us the direct decrease here. Okay, of total food grains decreased by 17.75 percentage points. Find the percentage increase in total food grains from 23 to 24. Find the total increase in or find the percentage increase in total food grains from the year 23 to 24. Okay, I hope you have understood each and every point, the information being provided that was provided here. Okay, now pause the video, solve for yourself. Okay, pause the video, solve for yourself, and then compare your answers with mine. Okay, and then update. Okay, update both the approach and even if you have made mistakes. Okay, see where have you gone wrong. Have you gone wrong in applying this thing, or have you gone wrong in reading the statements itself? Okay, so we'll see the solution in a few seconds. I hope every one of you have solved the question. Now let us see. Now at the outset itself, I see 37.5% here, 31.66% here, and 17.75. Okay. Now this is how you should approach. I see percentages which are not plain vanilla. Okay. That means they are not the normal percentages like 60%, 50%, 70%, where you could get away with taking the initial value as 100. But here the percentages are different. So the easiest way to solve this problem is by following the other two methods, which is either a ratio or multiplication factor, by using multiplication factor. And now the choice of initial value becomes much more important. If you take 100x, I am sure you will run into decimals and complexity of calculation. Okay, so your initial value should depend upon, because the percentages which are given are not normal. Okay, we need to choose our initial value carefully. So how will I choose? First, decode these percentages to ratio or percentages to fraction. 37.5%. Can I write this as 3 into 12.5%? Okay, 37.5% is 3 into 12.5%. Or you could see this as 50 minus of 12.5%, right? 50 minus of 12.5%. You know 50 is 1 by 2. 50 is 1 by 2. 12.5% is 1 by 8. 12.5% is 1 by 8. Now if you do this, 4 minus 1 by 8 or 3 by 8. Okay, this is one way of getting here. Or this is 3 into 12.5. 12.5% is 1 by 8. Or you could directly arrive at the solution. So in the denominator I have 8. Okay, so whatever value I use, the problem becomes much more simpler if the initial value is divisible by 8. So okay, instead of taking 100x, I take 800x as the initial value. So okay, so 37.5%. Okay, 37.5%. So if it is 8 parts, if the total, what does this really mean? If 8% is the total food grain production, if the total food grains produced are 8 units, in that rice means 3 units. That is what this ratio or this fraction means. Okay, rice is 3 units. If the total food grain production is 8 units. So so you see a super category, total food grains, rice. Okay, and both are produced in 2024 and 2023, right? So the easiest way is form a matrix. Easiest way to visualize, form a matrix. Total food grains. Okay, total food grains and rice production Now on one way we see 2023 and the parameters of 2024. Okay, so in 2023 rice production was 3 units if the total food grain production was 8 units. So what will be? So since I want the initial value to be divisible by 8, I'll take the total food grain production as 800x. I will take the total food grain production as 800x. So your rice production is going to be 300x. Okay, your rice production in 2023 is going to be 300x. Now what has happened? From 2023 to 2024, what has happened? The rice production has increased by 31.66%. 31.66%. You see, I hope you have observed this. all I am doing is interpreting a line by line, interpreting the problem line by line. Okay. If you see everything at once, it might seem too chaotic. But if you approach it line by line and present the information clearly, you will see how easy the solution becomes. So 31.66%. So what is 31.66%? I know, seeing this itself, okay, I'll run into some difficulties. So it is better to solve this, because this is not a classic percentage or a normal percentage. Okay. The best way to approach is through ratio. So how can I write 31.66%? Always think for, you see, how I have thought about 37.5%. I have always thought nearer to the comfortable ratio that I have. 37.5% is nearer to 50%, right? So I have thought in these terms. In the same way, what is this nearer to? What is the percentage that I am comfortable that is nearer to this? It is 25%. So can I write, you should also approach this in this way. Can I write this as 25% plus 6.66%? Okay. And take this value such a way that this is some percentage, you know. This is some percentage, you know. %6.66%. So 25% is nothing but 1 by 4. 25% is nothing but 1 by 4. And 6.66% is nothing but 1 by 15. 6.66% is nothing but 1 by 15. Or you could also think like this. Okay, one way of thinking 6.6%, you know, this is nothing but 66.66% by 10. Will you agree with me? 66.66% by 10. So what is 66.66%? It is nothing but 2/3. It is nothing but 2/3 by 10. So 2 ones, 2 5s. So what will this become? It will become 1 by 15. Or you could easily remember, because I told you, if you would have followed the previous classes, one important thing is we have already discussed in the second session, percentage to fraction conversion, and this is that. So this will give me the LCM is 60. The LCM is 60. So 15 plus 4. So this becomes 19 by 60. 19 by 60. So what does this signify? On a base of 60 units, on a base of 60 units, on a base of 60 units, there was an increase of 9 units. On a base of 60 units, there was an increase of 9 units. So this is nothing but, sorry, 19 by 60. 19 by 60. So 31.66% is nothing but 19 by 60. That means on a base of 60 units, it increased by 19 units. If 60 is 300x, if 60 is 300x, 60 is 300x, what will be 19 if 60 is 300x? So 60 into 5 is 300. 60 into 5 is 300. So 19 into 5. So the increase is 95x. The increase is 95x. So the total production becomes now, initially it was 300x and the increase was 95x. So it becomes, the total rice production is 395x. Okay. The total rice production is 395x. Now we need to find what was this. Now see what is the one more information given. Okay. Rice percentage as, so instead of, I told you at the first observation itself, okay, instead of giving you direct information, they will always give you indirect information. Indirect information. What has he given us? Rice production as a percentage of total food production decreased by 17.75 percentage points. You see, initially in 2023, we'll get back to that screen. He has given the rice production as 37.5 units. 37.5 units. And in 2024, rice production as a percentage of total food grain production, he says it has decreased by 17.75 points. 17.75 points. Let me just, okay, 17.75 0.75 points. So what will this be? So it has decreased by 17.75 points. So this will become 37.5 minus 7.75. So this will be 75 to 5. I need another 0.75. So this becomes 18. Okay. So in 2024, rice production as a percentage of total food grain production is 19.75%. 19.75%. Okay. So now let's get back to the previous session. Now, okay, there is some total food production, okay, and 19.75%. 19.75% is 395x. Okay, 19.7% is 395x. So now we need to find out this. So you see, so 19.75% of x is equals to 395 percentage. So what does x? X is percentage is by 100, right? So this becomes 39 by 19.75 into 100. So this becomes, this is twice. So this is sorry, percentages are there, right? Okay, so this becomes 2000x. Okay, sorry, I have made a mistake here. 39.5, the percentages are there. Okay, this is 20 times, so 20 into 100 becomes 2000x. So in 2024 the total food grain production was 2000x. Okay, I have done nothing. First I have found out the rice production, and rice production is 19.75 units. 19.75 units of the total. So if 19 point, what I have done is simple unitary problem. Okay, if 19.75 units is 395x, what is 100x? Okay, so I find that 19.75 is, okay, this is just twice of 39.5. Okay, 19.75 into 2 is 39.5, and I moved the decimals. Okay, so this becomes 2000x. Okay, so the total rice grain production is 2000x. Now, yeah, what has he asked for? Find the percentage increase in total food grain production. 800 became 2000x. So what was the change? 1200 was the change. And what was the base? 800. So it is 150%. Okay, so this is nothing but 4 2s are 8, 4 3s are 12. Okay, so initially it was 2 units, now it became 3 units. So what is the change? The improvement is by 1. Okay, so it has improved by 150%. Okay, 150%. Okay, so 800, 150%, 100%, it is 1600, and half of that 400. So it becomes 2000x. Okay, so you see, although the problem might appear complex, if you demonstrate, or if you represent the data in a matrix form, and try to find out the variable, or find out the values between all the variables, the problem becomes easier. Okay, see, this is a bit on the tougher side. Why? The percentages given are a bit complex. I wanted to give you, even if the percentages are complex, if you get the basic idea that if you arrange it in form of a matrix and find the interrelationship between all the variables given, the problem solution will always become easy. Okay. Now, I hope this has given you good food for thought. Okay. Now let's solve another one. Okay. Question number 3. Number of girls appearing for an exam. Number of girls appearing for an exam are 287.5%. Number of girls appearing for an exam are 287.5% more than the number of boys. More than the number of boys. Okay. If 58.33% if 58.33% of boys passed, if 58.33% of the boys passed, and 48.37 and 43.75% of the girls passed the test. Okay. So for an exam, both girls and boys appeared. Okay. And girls who appeared were 287.5% more than the number of boys. 287.5% more than the number of boys. And out of the boys who appeared, 58.33% have passed the test. And out of the girls who have appeared, 43.75% okay have passed the test. Find total percentage. Find the total percentage of failed students. Find the total percentage of failed students. Find the total percentage of failed students. I'm repeating for the sake of clarity. Okay. Both boys and girls appeared for a test. Both boys and girls appeared for a test. The number of girls who appeared are 287.5%. The number of girls who appeared are 287.5% more than the number of boys. Okay. And after appearing, 58.33% of the boys has cleared. 58.33% of the boys have cleared the exam. And out of girls, 43.75%. Out of the girls, 43.75% has cleared the exam. The examiner wants find the total percentage of failed students. Find the total percentage of failed students. Pause the video here. Try for yourself. Pause the video here. Try for yourself, and then we'll see the solution in a few seconds. It is important for learning that you have to try for yourself. Mistakes are good here. We'll just see the solution. I hope every one of you have tried the question. Now let's solve it. So first we'll follow the same pattern that we have been following. Girls, boys. And what are the subcategories? Passed, did not pass, pass, or did not pass. Okay. Now let's go by one. 287.5%. The girls who have appeared are 287.5% of the boys who have appeared, more than the boys. 287.5% more than the boys. What is, so let me write the calculation here. 287.5% more. What does 287.5% more mean? Can I write this as 200 plus 87.5% more? 200 plus 87.5% more. 87.5%. How can I write 87.5%? Same. Think in these terms. Find out the nearest comfortable percentage. Nearest comfortable percentage is 100. 100 minus, can I write this as 12.5%? Can I write this as 12.5%? So 100% is 1. 1 minus 12.5%. 12.5% is nothing but 1 by 8. So 1 minus 1 by 8, this is nothing but 7 by 8. 7 by 8. So 200 is nothing but, in the fraction form it is 2 plus 7 by 8. So this becomes 16 plus 7. 16 plus 7, which is nothing but 23. 23 by 8. Okay. 23 by 8. So 287.5% more. 287.5% more. Most people will make a mistake here. They'll think the number of girls are 23 and the number of boys are 8. No. This is not telling us how many girls are there. It is telling us how many more girls are there. You must observe the difference here. Number of girls is different. How many more number of girls is different. Okay. So what does this mean? That means if there are, for example, if I take 8x boys or 800x, okay, for simplicity's sake, because the denominator is 8. If there are 800x boys, the number of girls are 2, or let me take this as 80x. It becomes, okay, it becomes conceivable. Okay. If the boys are 80x, girls are 230x more. I am not telling the number of girls are 230. That is different. Girls are 230x more. So what will be the number of girls? Boys plus, how much are they more? They are more by 230x. So the total will be 310x. Okay. The total will be 310x. Sorry, this is not passed. Okay. So this is the total. The total number of girls are 310x when the boys are 80x. Now 43.75%. 43.75%. How can you write 43.75? 43.75 is, okay, I'm doing the calculation here again. 43.75% is 50% minus of 6.25%. 50% minus of 6.25%, right? So 50% is 1 by 2. 6.25. You see, 1 by 8 is 12.5. Don't you think 6.25 is 12.5 by 2? 12.5 by 2. So this is 1 by 8 by 2, which is nothing but 1 by 16. So this is 1 by 2 minus 1 by 16. So this is nothing but 7 by 16. So 43.75%. 43.75% is 7 by 16. Okay. Next, 58.33%. The same way. 50% plus 8.33%. 50% is 1 by 2. 8.33% is 1 by 12. Okay, 1 by 12. So 12, 6 plus 1. Okay. So these are the number of boys who passed. The number of boys who passed are for 58.33%. So 380. The number of boys who passed, or the number of boys who passed are nothing but 58.33% or 7 by 12. 7 by 12 of this. So what will this be? 7 by 12 of 80x. So this goes for 2, 6, or for 3s are 12. So 7 by 12. So 80x is becoming a problem here. So 140x by 3. Okay. So this is 140x by 3. In the same way, what was the total number of girls? Seven by 16. So the number of girls who passed are 7 by 16 of 310x. So 16, it only goes with 8. (155x). These ratios should not be here. Let me see the question clearly. The question seems to be correct. Okay. What can we do more? So this seems to be 7 into 155. 7 into 155 x by 8. 155 x by 8. Now I have a problem with this. 3 and 8. Okay. So let this be a good example. Suppose it is not that every time the examiner gives you those values which are easily cancelable. What if they give you ratios which are difficult to deal with? So what do you do in such time? Okay, we are able to see 287.5%, and we came to this conclusion: 80 and 310x. Now while going still in depth, while going in depth or while going into the subcategories, we are running into fractions. We are running into fractions. So what do we need to do? Simple. The easiest way to solve such problems is, what is it that is making your calculation difficult? It is this and this. Okay, it is these denominators that is making your calculation difficult. Suppose if I multiply, you know, ratio is a by b. If I multiply this by any constant, okay, if I multiply this by any constant, take this property. Okay, if a ratio a by b, if I multiply it by a constant k, the value will be still a by b only. Okay, so using the same, since this 3 and 8 are complicating my calculation, what I will do, I will multiply this by 3 into 8, because these two are interconnected, right? If one is 8 units, sorry, if one is 80 units, another one must has to be 310 units. If one is 80 into 3 into 8 units, another one also has to be 310 into 3 into 8 units, 310 into 3 into 8 units. Okay, once you see this here, now see how easily the solution becomes. Okay, so this is the case when you are unable to see, or when you are running into problem while dealing with fractions. Okay, I am telling you the easier way to solve such. It is just because it depends upon your initial value, and your initial value is not getting cancelled here, is not getting cancelled. So change your initial value even after doing the calculation. Even after doing the calculation, how will you do that? See what is obstructing you. Okay, the denominators are obstructing you. So multiply both sides of the ratio. Multiply both sides of the ratio by the denominators involved. So this becomes 80x into 3 8s are, or 3 into 8. Let me write it like this only, and this will be 3. Okay, so this will be 8 into 8. This will be 640x. Now this will be, this is going to be 7 into 310, 7 into, okay, let me do this. Okay, we need to find out 7 into 310x by 8. Okay, since this is getting into complications, what I have done, I have just removed the denominator by multiplying x into 3 into 8. This 3 saves the boys. This 3 saves the boys. This 8 saves the girls. So 7 3s are 21. 21 into, or this is 7 into 3 3s are 930x. Or we can also write this as 9 7, 9 3s are, sorry, 7 3s are 21, 2 9 7 are 63. Okay, 6510x. So this is 640x. This is 640x. This is 6510x. This is, so 80x minus, sorry, so 64 into 3, 64 into 3, okay, 12, 1920x. So this total value is 1920x. Okay, this total value is 1920x. Out of this, 640 have gone. So 640 to get to 1920, what is required? 640. If I add 60, 700. 640 plus 80 becomes 720, 1200 then. 1280x. Okay. In the same way here. This is 930x, 930x into 8. 8 3s are 24, 2 is remaining, 9 8 is 72, 74. So this is, in total it is 7440x. 7440x. 7440x minus 6510x. So 10 plus, so this total is those who did not pass the exam are 7440 minus 6510 for 40 and 10, 30, 74. Wait, we have made a mistake, committed a mistake here. So 1920x, 8 8s are 64, 64 into 3, 12 plus 3, 18, 1920x. So this becomes, this is 7 by 12. That is what I was thinking. Where did I miss something else? Okay. So this is simply 80x into okay 7 into, or let me simply write, okay, 7 by 12, 7 by 12 into 3 into 8 into 80x. Okay, 3 4s are 12, 4 2s are 8. So 16 into 7. Okay, 1020x. So 1020, that means there are 900x that are this thing. I think I made the same mistake here. 7 by 16 into so the number of girls who didn't pass are 43.75%. How much is 43.75? It is 7 by 16. 7 by 16 into 310 into 8 into 3. So 8 2s are 16. 2 into 155. So this becomes 155 into 21x. So 155 into 21x. It seems to be 21. Then 5 2. Okay. So this is 3 2 55x. So the remaining of this is, the total is 7440x. Out of this 3255x. So I'll add 55. What do I need to add to 55 to make it a 40? 55 plus 85. So 85, then this becomes 33. 33, 74 minus 33 is 4185x. Okay, so the total people who did not pass is, okay, 4185 plus 4185x plus 900x by the total number of these things are 3 into 8 into 310 plus 80. $390x. So 4185 plus 90. So 5085x divided by 393 into x. Okay, let us write this on 388 into x and go on. So we need to just find the approximate percentage here. 3 into 8 is, okay, 72 plus 24, 3120 into 30691. Okay, so 5085x by 9160x. So approximately, see, 91. What is half of this? You need not get the accurate percentage. If it was this 4500 is, it's half plus something extra. 160 is 80, so half of 160 is 80, so 4500, so 4580. But we got 5085. This is something more. How much more? 505. So 505 more. So this is half percentage. So and 505 will be 916. 10% is 916. 505 is around 5 6. Okay, so okay, the whole percentage is around 56%. Okay, approximately, whatever the option which is near 56%, you can choose that. Okay, so although the principle behind are same, but because of these calculations, because of these random variables only, we had to go this long. But the principle behind is simple. Draw a matrix, find out all the individual, fill out all the individual tables. You see, I'll tell you the metasense in simple words. Okay, first we were given the total values. Of boys and girls, and out of this, some percentage of boys and some percentage of girls have passed. Some percentage of boys and some percentage of girls have passed. So we need to find out who did not pass. So once we find out these two values and then we subtract from the total, what are we going to get? We are going to get people who did not pass, and this by the total number of people gives you nothing but this. Okay, only because the percentages involved are a bit complex, we had to take this much time. Normally the examiner won't check on this scale because everything was getting complicated. Okay, normally they'll give you a cancelable fractions only, but it is good that we have encountered this. Why? It teaches us, okay, if you encounter fractions while solving the problem, we can simplify it by changing our, okay, it is not that you keep your initial value as it is. We can change our initial value and simplify the calculations. Okay, so we learned one more thing apart from application to matrix problem. We learned in this problem, way to solve, or the way to change the initial value, way to change the initial value post facto, or post calculation, post calculation. Okay, now we shall see a last problem in this, and then we'll end this session. Okay. There are there are there are 20,000 people or 2,000 people. There are 2,000 people in a village. There are 2,000 people in a village. There are 2,000 people in a village. Of this, 58% are males. Of this, 58% are males. Of this, 58% are males. Okay. And the total literate population, of the village, the total literate population of the village is 8,600. The total literate population of the village is, okay, 8, okay, when 2000 it can't be, okay, the total literate population is 860. The total literate population of the village is 860. Okay. If there are if there are 78 78 78 more 78 more male illiterates, 78 more male illiterates, 78 more male illiterates than female illiterates, if there are if there are 78, if there are 78 more male illiterates than female illiterates, okay, what percentage of, I want to find out what percentage of female population, what percentage of female population is illiterate, what percentage of female population is illiterate, what percentage of female population is illiterate, what percentage of female population is illiterate. Okay, so there are 2,000 people in a village. There are 2,000 people in a village. Out of this 48% are males. Sorry, out of this 58% are males. The rest are females. And out of this, the literate people are 860. The literate people are 860. And if there are 78 more male illiterates, if there are 78 more male illiterates than female illiterates, if there are 78 more male illiterates than female illiterates, find the percentage of female illiterates. Find the percentage of female illiterates. Okay, pause the video, solve the problem, and compare your approach with mine. We'll see the solution in just a few seconds. Okay, let's solve the problem. So are you identify the meta category here? There are in a super category of males and females, there is a subcategory of literates and illiterates. So this is a prime candidate for matrix based problem. So there are males and females, and both have literate, illiterate, illiterate. Okay, so males and females, literate and illiterate. Okay, total. Okay, out of 2000 people, so I'm going to do all my calculations here. Out of 2000 people, 58% are males. 58% are males. So how many are males then? So 58 into 2, 58 into 2, okay, percentage cancels 2, so there is 1 0 left. 58 into 2 is 116. 55 2s is 110, and 3 into 2 6. So the total number of males are 1160. Okay, so what will be the number of females? It will be 40. So this becomes 1208. Okay, so the number of females are 840. So the total number of males, okay, the total number of males are 1160, and the total number of females are 840. Okay, total number of females are 840. And what is the one more information he has given? Literates. Okay, if the total number of literates are 860, if the total number of literates are 860, okay, if the total number of literates are 860, you see here itself you could see the pattern unraveling. Okay, he has given us literates, we have to find out the illiterate among females, So what do I need to find? I need to find first illiterate value, right? Illiterate value. Okay, out of the total he has given 860 are literates. So what will be the number of illiterates? You see, you can make a connection here. Even instead of doing 2000 minus 860, you see 840 has increased by 20. That means this has increased by 20. That means this value has decreased by 20. So it will become the number of illiterate people are 1140. The number of illiterate people are 1140. Number of illiterate people are 1140. Next, what is the second one? If there are 78 more males, if there are 78 more male illiterates, if there are 78 more male illiterates than female illiterates, if there are 78 more male illiterates than female, let us assume, okay, female illiterates are X. Let us assume female illiterates are X. Male illiterates are 78 more. So X plus 78. Okay, X plus 78. Once you do this, okay, you see the addition of these two is 1140. How many variables are present? One variable, one value. So one equation is sufficient. So 2x plus 78 is equals to 1140, which takes us 2x is equals to so how much to 78 gives me 40? 78 2 and 6. 62. 62 it becomes 140, 1100. Sorry. $140,000. So 1062. So X is equals to X is equals to 5 3 1. Okay, so the number of female illiterates, are 531. What has he asked for? The percentage of female illiterates, total percentage of female illiterates. Total females are 840. Okay, total females are 840, illiterates are 531. So percentage of female illiterates is equals to 531 out of 840. So the approximate percentage is going to be 840. 840 half is 420. And how much is this more? Approximately by 110, right? 531 or 111, we can take it as 110. Okay, so this is 50%, and 10% is 10% of this is 84. How much is 110 more than 84? 36 more. So 50 plus 110, this is already okay. 110 is 84 plus 26. So 50%, 420 is 50%, 84 is 10%, 26 is 5% of this. Okay, 5% of this is 42. Okay, 26 is 16 less, so around 3%, probably around 3%. Okay, so the approximate percentage is going to be 63%. So 531 by 840. Okay, so choose the option which is near 63%. Now, okay, once you frame this, once you get into this matrix mode, okay, they can ask you anything, and you can without any iota of doubt, you can give you, suppose they might ask you any of the variable from this sort, total male. Okay, they can ask you total male percentage, total male literate percentage, or they can ask you how many male literates are more than female literates. Everything is possible with this. So this is 531. So this is 531 plus 78, 9, 53 plus 7, 60. Okay, so now from this we can get number of male literates. 609 1160. So 9 plus 51 is 660. 11 minus 6, 5. Okay, 560. In the same way, 840 minus 531, 9. Okay, so 309. Okay, once you get all the information here, okay, any value they ask is just cakewalk. You need to find out whatever they ask you, whether how many male literates are more than female literates, or male literacy percentage. Everything is possible from here. Okay, so arrange instead of getting confused. Okay, so all these problems that we have seen today tell us few things. So one, okay, if you are unable to see the bigger picture, okay, always approach a question in step by step. Okay, understand a sentence and know its full meaning, know its full interpretation. Okay, and then go on to the next. And next, when problems are of this sort, where you have a super category and that super category has subcategories within it, all you need to do is find a matrix. Okay, all you need to do is form a matrix and fill out all the possible blanks. Fill out all the possible blanks. Okay. Whatever value that the examiner asks for will just come from the matrix itself. So I hope I have given you enough idea on matrix based problems, and you have learnt many things. Okay, apart from the theoretical based concepts, you have known how to practically deal with tricky percentages. So I hope you have learned something new from this session today. Okay, in the next session we are going to see applications of percentage, which is nothing but profit, loss. Okay, profit and loss. So the next session is going to be on profit and loss, and even in profit and loss we'll see niche areas like okay, or like problems on unconventional definitions. Okay, unconventional definitions, where one example of this is your profit is always defined on cost price. What if it is done on selling price? What does it change? And next such things like and one more category of problems are numbers based. For example, 5 pence are brought at 1 rupee and they are sold at a cost of 3 pence for 2 rupees. Okay, so such number based problems. And next you'll also have relationship between markup percentage and all. Okay, so there are 3 or 4 niche categories which are not dealt regularly in classes, in any of the classes. So what we'll do is we'll pick up these niche topics, and so in the next session I hope many of you will participate just like today. We are going to see basics of percentage. I hope next class we'll spend a little bit more time, because it is the first time that we are dealing with profit and loss. We'll deal a bit in depth the theoretical portion, and then we'll solve each of these niche categories as much as the time permits. Okay, so I hope most of you will attend the next session too, and I have enjoyed teaching you. Thank you.